Hello, everyone, and thank you for joining today for MidNite Solar's Product Updates webinar. Just a few quick things before we get going today. So during the webinar, all attendees will be muted for best audio quality. If you have any questions throughout the presentation, please feel free to use the Q&A button at the bottom of your screen. Those questions will be monitored. This presentation will be recorded and shared with all of you within 1 week of today's session. And please join me in welcoming today's presenter, Ryan Stankovitz. Ryan is an applications engineer at MidNite Solar with over 22 years experience in the solar industry and is a master electrician for about the past 34 years. So without further ado, I will pass it over to Ryan to get us started. Thank you.
All right, thank you. And thank you everybody for taking a little bit of time out of your day to listen to me ramble about our new products. I'm going to go through all of our new offerings for 2023, and hopefully we have a lot of questions and I can answer a lot of those. So without any further ado, I'm going to jump in. I always like to introduce who MidNite Solar is. I forget that not everybody has been in this for 20 something years as well. But we get our roots from way back in the trace engineering days. We founded Outback Power. Some of the employees from Trace went and started Magnum. And then, our founders, Rob and Gudgel, started MidNite. And it's kind of cool because now we have a little bit of everybody. For those of you that have done work with Magnum Energy, you'll recognize names like Gary Baxter or Tony Boatwright. They work at MidNite. Same with Outback. We've got some of the engineers there, and even back to the trace roots. So it's pretty cool. We've really we consider ourselves very innovative. We're an American-based company. We do all of our work right in Washington State. We populate circuit boards, the whole 9 yards. Really, really pride ourselves in trying to build stuff, in North America versus just farming it out. And kind of one of the last men standing for that, if you will. So yeah, we will jump in here, and without further ado, I want to jump right into the Rosie. So this is our most exciting happening. We are finally selling our inverter. It's a 7,000 watt split phase 48 volt inverter. It is high frequency. We're going to go through all of the ins, outs, and arounds of this thing as we go on. Currently, it is available in 2 models. It does have matching e-panels, and it also has complementary 600 volt MPPT charge controllers that we'll talk about that have been released as well. So very exciting stuff. One of the really exciting things about the Rosie, 7,000 watts continuous, but this thing will surge to 20 to 21 kilowatts. It's like 3 times surge, which is kind of unheard of. And it's pretty impressive. It really didn't comprehend it myself until I actually helped set up the booth for SPI, and we had 4 great big DeWalt air compressors and 11 kilowatts of light. And you started playing with this thing and you realize what that surge power really is. And it's kind of interesting because not only does it have the surge power, it's also very extremely robust. One of the engineers had wired something up wrong in the trade show booth, and every time we turned Rosie on, it made this really loud, just grinding sound, if you will. And then it would shut off. And around the corner came Andy, who built the Rosie, and he goes, "Oh, it's shorted out." And we started looking, and sure enough, L2 was shorted to ground in the booth. And we had started Rosie into a dead short probably 20 times, and it didn't have any problem with that. Um, some of the other neat things about the Rosie, it does have 2 auxiliary terminals, 15 or so different auxiliary options, things like diversion, vent fan. There's also inputs for things like a light switch application. So if you're putting this in like a cabin where you want to turn it off when you leave, you don't have to go to the Rosie. You can flip a light switch or force things like EQ or float by a contact closure. A lot of different functionality there. Rosie does also have 2-wire AGS by default, no add-on modules. Right out of the box, 2-wire AGS. I think we have a slide on that, so I'll wait and talk about that when we get there. Listed to 1741, UL 458, and CSA 107.01. The 458 and CSA are brandy new. We have been I don't want to say fighting with the listing agency on this one, but it's been a slow road to get the paperwork, and we actually have that now, so that's really exciting. 120 amp power factor corrected battery charger. Another thing we do with the Rosie is it does talk to our Whizbang Junior. So you get state of charge with the Whizbang Junior. And this becomes important because I like to talk about equipment like the Rosie is software driven. The days of like the trace inverter being kind of an analog hardware device. Now we're into the software world where we do a lot of these different things. And with lithium batteries and a lot of the newer battery chemistries, state of charge is much more important than voltage. So we're doing things on state of charge like low battery cutout. If you want, you can select either one. Start, stop your generator. You can do a rebulk on a state of charge now instead of voltage if you want. It's selectable by you. So that's kind of a neat feature. The Whizbang Junior does come in the Rosie E panel, which we'll talk about a little later. You can also use, like if you're using a battery combiner, if you're doing a big system. One of the new features that was just released yesterday, actually into beta firmware, which will go into production here in about a week, is stacking. The Rosie does now stack. It has a lot of cool features that we'll talk about later about like grid support and whatnot. It does come with the battery temperature sensor, and that is kind of important. One thing the Rosie does and all the new equipment does is it actually uses a battery temperature sensor for more than just compensation. So if you've got a lithium battery, we can tell it to stop charging at this temperature, if it gets cold, or stop charging at this temperature if it gets hot. So we have a lot more programmability around that battery temperature than just compensating the voltage, like we're used to on lead acid batteries. So that's all built in. And we talked about the E panel. We'll get to that in a minute. The electrical specifications for the Rosie, as I mentioned, it is 7 kilowatts, 122, 40, 60 hertz on a 48 volt battery. It has a 60 amp transfer relay, so 60 amps per leg, 120 volt leg. That said, you can actually take the Rosie, go in programming and tell it you want it to be an export 230, 50 hertz, and it will do that for you. There's a bunch of, warnings and caveats that you make sure you're not connected to your system while it's running and all of that. But you can also configure the Rosie as a 120 volt only inverter if you, for some reason, needed 7 kilowatts at 120. The other thing the Rosie does that's kind of cool is it will take a 120 volt generator and power 240 volt loads. So if you've got a small camp or something, or you got a house and you just got a small little generator, it will take that 120 volt generator and it will, make the other leg like the Magnum Energy stuff used to do. That's kind of a neat feature. The mobile Rosie, we'll talk about that in a little bit, but the mobile Rosie has some cool adaptions as well. It will auto detect 120 versus 120 240. So if you're in a big RV and you've got the mobile Rosie and you plug into a uh, like a 50 amp dog bone, 30 to 50 amp dog bone, it will detect that the phases are in phase and it runs on both phases like that in phase. Or if you plug into, well, very soon now, if you plug into a 208, two legs of 208 three phase, which is actually more common in an RV park than one might think. We just found this out actually. It will auto detect the 208 and run on that as well. So the mobile Rosie has a little flexibility in that. Uh, One of the neat things about this, up until now, everything we've done has been pieces and parts that all kind of go together. The new system really is a system, and it is very easy to program. You're going to go through, you're going to pick your battery chemistry, lithium, whatever it may be, or, soon you'll be able to pick closed loop. We're really close to having closed loop with several lithium batteries. I think Home Grid, I'm drawing a blank on some of the names now, but it's some of the big names. I think there's 4 of them we're currently working with, and then we're getting ready to work with more. But the battery menu is really very straightforward. You program your battery specifications, your low battery cutout, your rebulk, all those parameters that you need to program, and it's auto populated to everything. The other neat thing is, let's say you buy a system and then, a little bit later you decide you need a little bit more charge controller and you call up and you order a new charge controller. When you plug that in, it just automatically gets adopted by the system and it takes all the settings from the system and just goes to work. And the same like with the Rosie, you can just keep adding Rosies. Stacking, we're talking about probably 10 is going to be the limit on the Rosies. Right now we're supporting 2. but engineering is gearing up to start testing 6 in parallel. And basically the way that works, it's very similar to like the Snyder systems, or the old Outback systems, where the primary Rosie will basically monitor what everybody's doing and the loads. And if you get a big load that comes on, it will turn on all the secondaries or the followers, whatever terminology you want to use there, and it will power that load, and then it will start dropping them off. So if you have, say, 4 Rosies, that's 28 kilowatts of power. And if you turn on a 10 kilowatt load, the first Rosie is going to turn on the other 3, and then when it sees it's only 10 kilowatts, it's going to turn a couple of them back off. And you will be able to disable parallel threshold as well if you want. One of the reasons for that really is if you've got you got one singular very large load. If that hits on a system where your parallel threshold is enabled and your followers are actually off, waiting to go to work, you lose a little bit of surge capability in that case, and it can be a little bit of a lag while those come on. I mean, it's milliseconds, but it's there to like a motor load or something. So you can tune that out if the system is large enough and needs that. And let me see if I can find my arrows. There they are. So some more specifications. 35 watts idle while making power. So, you turn it on, it's making 240 volts out. It's drawing 35 watts. If you put it into search mode, it draws 5 watts. Search mode won't behave well. Let me rephrase that. Search mode will behave similar to what you used to, as far as you can set the wattage that you want it to come out of search on, but you're not going to hear that ticking noise like you heard of the old transformer based inverters. And you're not going to see the flicker and the things that are like, if you had a little bulb on there, you'd see that flicker until the inverter come on. It does it a little differently, but it's the same function. If you set it for 20 watts, when the load hits 20 watts, the inverter turns on. Something else new for MidNite, the system has battery voltage sense. So there are a pair of terminals in every one of the products. You only need to use one, but that pair of terminals will actually allow you to connect it to the battery with small gauge wires. And that will tell the system what the actual battery voltage is. So if you've got longer cables or whatever the case may be, and there's some voltage drop under heavy load or heavy charge, that battery voltage sense will compensate for that automatically. No input needed by you. Just hook up the 2 wires. We talked about the AGS. Full functionality starts on voltage, time, state of charge. There are quiet time, blackout windows. It has the ability to stop on any of those, as well as like going to float. And you can start on one and stop on another. It's very flexible in how you can program that if there's a reason to. There's also load shedding. If the load is too big, we can shed the load over and start to generate. There's a lot of cool stuff there. Battery agnostic. We really don't care what you use for a battery, as long as it's between 40 and 65 volts. And as I mentioned, closed loop coming with home grid discover. I think there's a Renogy battery, and I was thinking maybe simplify, but I'm drawing a blank on some of those names. If there's a particular lithium battery that you enjoy and you want to entertain closed loop, just reach out to us over here at MidNite, or Charge Solar, and they can get that information to us, and we will start trying to open those doors. We're just basically as time allows between our engineering and the battery company's engineering, we're picking these off as we can. So the Rosie does require an interface. We call that the MNGP2, because those of you familiar with the classic, that has an MNGP, stands for MidNite Graphics Panel. So you do need one of those to set up and program the inverter. The Rosie will physically not work for you unless you have a display to program it. You can remove the display and take it with you if you want, but you do have to have that to program it once. And we did that mostly because we found way too many people just pick default values and go, and batteries really, really, really need you to program the proper variables in the equipment for those batteries. In my years in tech support, it would horrify me how many times I took a call where people had no concept of the charge settings for their battery. They just wanted the product to work. And it's like, if you undercharge that battery, you're going to destroy it. If you overcharge it, you're going to destroy it. And of course, lithium's a little more flexible, but if you get too far out of bounds, you'll run into the BMS, and that creates a lot of headache too. So you do need that, but it will also come with one of the charge controllers. So if you are, you know, if you're buying a Hawke's Bay or Barcelona, you're going to get that MNGP2 as well. And you only need one per system, but you can have as many as you want. So if you want a second one, you want to put it a couple hundred feet away in the house, you can do that. So I'm going to venture a little bit out of specifications and more into functionality. The one thing the Rosie doesn't do right now that it is going to do very soon is export to the grid. It'll do everything else, but it will not export to the grid right now. So I like to say it that way because that is the one feature I don't want to overlook, saying that it does not physically sell to the grid at this moment, but that is the next feature to be worked on. We anticipate that taking a couple months to get done and then probably about 30 days to get evaluated by the listing agency. But currently it does grid support, which allows you to offset the grid usage, and that's all automated. So if you're getting, like, if you put it in SOC or battery voltage grid support, what that will do is, like, let's say you set it for battery voltage and you tell it at 54 volts, I want you to, power the loads. At 54 volts, the Rosie will start supporting the loads with battery power to maintain 54 volts. So you may have, say, 1,000 watts of solar and 2,000 watts of load. It would draw 1,000 watts from the battery or from the solar, and it would draw 1,000 watts from the grid. And it can vary that based on what you have available. So that's a really nice, like, kind of grid last type thing, or grid zero, you may want to say. And that can run on state of charge or battery voltage. It will also allow you to obey breaker size on the input. So if you've got a small generator, or some reason you've got a small breaker coming in, you can set that for, say, like 10 amps, and that will then never exceed that 10 amps, and it will pull the rest from the battery to power the load. So that's kind of a cool feature. VDC connect or disconnect is a little bit like grid support, but a little different, where that will basically open the relay. So where grid support can actually add to the grid. So if you have, say, a 2 or 4,000 watt load and you only have 1,000 watts of PV available at that moment, it can take the rest from the grid. VDC connect slash disconnect actually opens the relay, and everything is coming from the solar system at that point. So you could have that set for, like, and a good example is my system in Florida. I don't have a net metering agreement, so it runs my air conditioning and everything. And I have that set to connect at about 20% state of charge on my lithium, and then disconnect again at about 40, because I'm like, I don't mind abusing the batteries, but I don't want to pay a light bill if I can help it. There's also time of use for blacking out, certain times of day to not use the AC input. So if you're trying to kind of do, load shift from one time to the other, if you will. And we do have a question about the export. Will export be a firmware update to units in the field? Yes. So if you want to do 230 50 hertz, you can do a firmware update and you will have that. That firmware is actually available today as beta firmware. There is a tab on our website called software, and you go there and you will find a cell phone application for what we call beta firmware, and a cell phone application for what we call production firmware. The difference between those two is beta has been tested by about 6, 7 of us pretty extensively for about a week, and then it goes into beta. And then the production one is tested by a larger group. Basically, once it goes into beta, we have probably another 24 people that play with that and beat on it for about 2 more weeks before we move it into production. So it's just another level of verification that we not have any abnormal behavior or any weirdness in that firmware. But that is just a firmware update, and currently it's an Android only. We have the iPhone updater done, and we failed the review through Apple because the user experience wasn't pleasant enough or something. I can't remember the exact thing. So we had to make some prettier icons and stuff like that to get that, and that is going back through review as we speak. So we're hoping that will go through this time. But yeah, 230 50 hertz is a simple firmware update, and then you're good to go. So a little bit of differentiation between the mobile Rosie and the RE Rosie, and I'm not sure just how much anybody in this group plays with mobile application, so I won't spend a lot of time on this, but know that the RE version, renewable energy version, is listed to 1741 and the CSA standard. The mobile version is listed to all three. Now, the really difference between the two is that the mobile unit has neutral to ground bond switching for those type of applications where, what that means basically, if you do any electrical work, you know that there's one place in the electrical service in the residence that you're supposed to bond neutral to ground. Usually it's done in either the meter socket or the main breaker panel, or that sometimes is one and the same. And it's going to depend on where you're at, your jurisdiction, et cetera. But that bond is only made in one place. So if you used a regular, say, Rosie in your RV, you would have to put a physical wire in the RV between neutral and ground to make a bond in the RV so that it was bonded while you were, using it. But then if you plug into a shore power somewhere, you would have a second bond, and that violates code. So a mobile inverter has another relay in there that basically unbonds it. Well, it actually bonds it when it's not connected to shore power, and unbonds it when you connect to that shore power, so you only have a singular bond. That's the biggest difference. There are a few little firmware nuances that are different. Like I talked about, the mobile version being able to auto detect 120 in phase, like if you're plugged into a 30 amp receptacle in an RV park with your 50 amp connector and a dog bone. But other than that, hardware wise, are identical, same surge capability, same hardware, same everything. Just one has that neutral to ground bond switching. So now I move into high frequency versus low frequency, because this is probably one of the biggest hurdles we've had to, I don't want to say overcome, but it's kind of you hear all these people talk about high frequency cannot do this, it can't do that, it won't do this, it won't do that. I will say that, like, Solarc really plowed the road for us. They came out of front and they did some work that has helped with that. But I want to talk a little bit about what high frequency does for you versus low frequency in some of those. So the biggest one that I want to talk about is the zero transfer time, or load transfer, if you will. So I can tell you from experience, having done this for 20 something years, I worked for Magnum Energy for a while. I can remember they flew me halfway across the country because we had a Magnum inverter that the relay was stuck on, because the loads were great when the relay transferred and the wiper got stuck. And that's not uncommon in a battery based inverter, where if you've got a huge load, if you look at the example on the left, your box on the very left is your loads. Then up at the top is your grid, and at the bottom is your inverter. So when the grid is present, that relay actually moves the arm over and connects the loads directly to the grid, disconnects from the inverter. So there's an arc on the relay there, and then it connects to the grid, and there's another arc there, because it's all under load. On a high frequency inverter, the loads never move. The loads are always connected to the inverter. All that relay does is parallel in the utility grid or generator, and it does that at absolute zero load. So because we control that, we match the grid 100% in voltage and frequency and phase. We close the relay at zero load. And then what we do, if you want to charge the batteries, is you start, lowering the voltage on the inverter section, which will then make current flow from the grid. Or if you want to sell to the grid, you raise the voltage on the inverter section and you force power to the grid. But the point being is that you'll have basically zero transfer. It's almost invisible in a light to see. How normally when the relay would close, you'd see a pretty good clunk in the light, if you will. That's pretty much gone altogether, and the relay never works under load. So on larger systems, you're not going to have that relay failure like you're familiar with. So that's one of the very big assets of high frequency, really. And then some of the other ones you'll hear is surge power is less of high frequency. And this just isn't true if you build it correctly. One of the things where this comes from is that you can go to any, little hardware store, Walmart, Amazon, your any one of your auto parts stores you have, and you can buy these very inexpensive modified sine wave, generally speaking, high frequency inverters. And those inverters will not surge. That is true. But if you build it correctly, you use the right parts. We use some pretty fancy silicon carbide FETs in there, and the surge power is just amazing. I can promise you that it's best in class. Like, you will not be disappointed, and you will not find a traditional battery based inverter that will outsurge the Rosie when it comes to that. Um, Another common sort of myth, sort of not myth, is load imbalance is important. So what I mean by that is, if you had, say, a Outback Radiant, you have a transformer inside the Radiant that balances L1 and L2. So if you put 7,000 watts on L1, the transformer is going to balance the inverter modules, and they're going to run, equal. Whereas if you put 7,000 watts on L1 of a Rosie or something like a Solar, it all has to come from L1 because there is no transformer. It's a high frequency inverter. So knowing that Rosie's 7,000 watts, it's actually, if you want to think of it easier, you cut it half and it's two 3,500 watt inverters. One makes L1 and one makes L2. So while it is important to balance your loads some if you have a lot of 120 volt loads, it's not like super critical, because remember, Rosie will surge to 10 kilowatts per leg. So, if you've got a ton of 120 volt loads, just kind of spread them out one on each side of your breaker box so that they're balanced. And that's sort of the electrician in me. That was one of the things I was taught. That was one of the things that our code in the States actually tells the electrician he has to do, is try to balance those loads. So that's the one thing that you do have to pay a little attention to, because you don't have that balancing transformer. One of the benefits is less weight. I think we talk about it a little later, but Rosie is 7,000 watts and weighs 42 pounds. So that's pretty impressive for anybody in the room that's installed a XW or a Sunny Island, or even a Radiant has got quite a bit of weight to it. That's much easier on our backs. We talked about the voltage being selectable in software. That's another feature of high frequency. You can't do that with the transformer based inverter. And then the other one that I hear a lot is that high frequency will struggle with inductive loads. And that, again, it kind of goes right along with number one, where the surge power. And if it's built correctly, it will not struggle. The inductive loads, I can remember back in our Outback days, we ran into some wash machines. I can remember there was one particular wash machine. I can't remember the brand, but every time the wash machine would come on, the inverter would do something really weird, and the circuit board in the wash machine would catch on fire. And I remember working with engineering, and they made some changes and tuned that out. But that's one of those things where inductive loads can be really weird. But generally speaking, most of our loads are going inductive in a way, because all your lighting has gone away from incandescent. You have LEDs with circuit boards and drivers in there, and it's just gotten way easier in software to build a device that doesn't care about that kind of load anymore. We've been testing. I've personally been running a Rosie for almost 2 years, and we haven't found anything yet. And with several hundred out there in the world now so far already, no problems being fed back to us on loads that we're not seeing. But like I said, every inverter might have its one load, but if there is a little problem, usually engineering can tune that right out. And we do have a question on how long will it surge at 10 kilowatts. So this is an interesting, fun thing to look and play with. So if you're bored and you really want to sit down with a beer and really go do some research, every inverter manufacturer talks about surge time and surge numbers, and they're all different. And so in a nutshell, when you go through UL, you go through any what they call NERDL, nationally recognized testing laboratory. The current UL 1741 says that you can do unlimited up to, I believe it's 5 minutes. And then from 5 to 10 minutes, you can do 125%. And then above 10%, above 20, yeah, I just screwed that timing all up. 0 to 5 minutes is unlimited. 5 to 10 minutes is up to 125% of your rating. and above 5 minutes is 110% indefinitely. So in other words, the Rosie can run at 7,700 watts forever, according to UL, and at up to 5 minutes, it can run any number you want to run. So obviously, it's not going to run 20 to 21 kilowatts or 10 kilowatts per leg for 5 full minutes. It's going to get hot and it's going to back down or shut off. But it will, depending on your ambient temperature and everything else, you're probably going to get, I'm going to say at 21 kilowatts, you're probably going to get about 2 to 3, 4 seconds. At, maybe 15 kilowatts, you're probably going to get almost the full 5 minutes. So it's just going to depend on the amount of surge, the length of the surge, and the ambient temperature. But the fun part is, like I said, one of my jobs was to sit down and say, okay, what does all of our competition do? And I started making a spreadsheet so I could try to compare surge power over time. And every inverter I found used different times and different numbers, to make it work. And I think one of them I looked at even said it called out very specifically in a 25 degree C environment or something like that. And my engineer's like, so if I take the air conditioning in the room and I set the room to 25C and I take a 6-inch pipe out of the air conditioner with a fan and blowing that through the Rosie's technically in a 25 degree C environment, but it's being force cooled. Does that mean I can go? So in a nutshell, I think you're going to find it's going to outrun pretty much anything on the market. One of the testimonials I got the other day was a customer had an XW Pro 6848 and I think it's a CNC plasma table, and that requires an air compressor, I guess. And on long cuts, he didn't define long, but he just said on long cuts, he would normally have to fire up his generator because the XW would only do about like 3 minutes with the air compressor and the plasma cutter running before it would, thermally shut down. And he was able to run a 15-minute cut on the Rosie, and he finished his cut without having to fire up the generator. The Rosie didn't shut down. I don't know if he's gone longer to figure out where that trip point is, but it really it's again it's a lot of playing with numbers and time, but I think you're going to find it's best in class when it comes to any of that. So the breaker box is really not a lot to talk about here. It looks just like the Rosie. It fits nicely to the Rosie. It's got bus bars inside for the negative and positive. It does have the Whiz-Bang Junior, as I mentioned, in the shunt. You'll notice that we've gone to what we call a Z-wire for the bypass. So anybody in the room that's used our E-panels in the past, especially the one for the Snyder or the SMA, knows that when you take the dead front off to work on it, you take the bypass slider off, and now the breakers are no longer interlocked. And that always sort of bothered me a little bit. So the Rosie, we're transitioning to the Z-wire and everything, but on the Rosie E-panel, that makes it really nice because with the dead front off, the breakers are still interlocked. You got a 60 amp bypass, 60 amp input, 60 amp output breakers, connections via surge protection. There is an optional back plate, and you do have your 300 amp battery breaker there to go with it. We are working right now today on the follower E panels to allow you to stack two. And then we're going to be working on a 120 amp primary E panel for a stacked pair. Because remember, the Rosie has a 60 amp internal bypass. So if you had two Rosies, you could theoretically pass through 100 amps to back up a 100 amp load center, in a resident. The Rosie itself, so we're going back to system and weight and, talking about the advantages of low frequency. The Rosie itself has keyholes on the top of it. So at 42 pounds, it's still pretty light, but when you're putting it on the wall, you can, slide it down over the keyholes. So you can do the pre-wired in several ways. You could set the back plate right on your workbench. You could set the Rosie and the E-panel on there, bolt it all together, pick this thing up and put it on the wall, because completely assembled, ready to rock and roll is 62 pounds with the Rosie, the back plate, and the breaker box. What I like to do is I like to put the breaker box on the back plate on the wall, and then I roll the Rosie on top of it. There's a big hole in the bottom of the Rosie. There's a piece that comes off when you're using renewable energy. It's probably, I'm going to say, 3 or 4 inches across by 3 inches deep, and that allows all the wiring to come right up through, and it's just very simple to install. But one of the cool things about this is that because it is so light, you can do like a pre-wired Rosie with the Classic, or a pre-wired Rosie and a pre-wired Hawke's Bay, or a pre-wired Barcelona for that example. And they're all UPSable. So you could actually get, if you were in a bind, you needed one in a hurry, Charge Solar could ship you one out UPS, expedited, and you can have it in a real hurry. Whereas traditionally a pre-wired system has been heavy and had gone truck freight. So that just opens a few doors on shipping and makes that kind of nice. Plus, as I said, it's way less backaches. Having lifted a lot of XW Pros and way too many sunny islands, I can tell you this is a lot nicer to install. So I'm not going to spend much time on this. This is just a CAD drawing of the electrical connections, showing you where your connections go and how the inverter wires up to it here. Uh, it's really explanatory. There's a good manual with it, and everything's very well labeled. I will say probably one of our best products when it comes to labeling. So I'm going to transition over into charge controllers for a little bit, and then go into a couple other new products for this season, and then let you guys get on to lunch. So we're going to talk a little bit about the Barcelona and the Hawke's Bay. They are both 600 volt MPPTs. They are both 48 volt only, and they both speak CAN bus just like the Rosie, and they all communicate together. That piece you see on the front there with the display and the rotary knob and the buttons, that is what we call the MNGP2. So you need one of those per system, but you can have as many as you want. So some electrical characteristics and some feature sets. The Barcelona is probably the largest MPPT charge controller that I know of in the market. It's 200 amps, 48 volt DC battery, and 600 volt DC input maximum. It is dual MPPT, so it's true dual MPPT. It has two complete different power sections to track two complete different arrays. So 100 amps per side, and one singular control section. The MPPT range is 185 to 585 VDC. It will turn on at 599, so it will run all the way up to basically 600 volts. And talked about the dual inputs. It also has the remote battery voltage sense, which we really kind of beat on before, but this has that as well. And again, you only need one per system, and that's true of any sensor. So if you have a battery temperature sensor, a remote battery voltage sense, or a Whiz-Bang Junior, you only have to have one per system, and the system shares that data amongst everybody. If you accidentally install more than one, don't worry, the system will ignore all but one of those automatically. And it does also coordinate everything automatically. So all devices will go to float or bulk, at the same time, or EQ or whatever you've got programmed in. The other thing we did with the new products is we now have a ground fault device that is optional that will allow you to solidly ground the negative. Now, I'm not 100% sure where you guys are on code up there in Canada, but I know here in the States, we've got this thing called like reference grounded and solidly grounded. And if the system is reference grounded, the way they word it, actually, let me back up. The way the code here words it is any conductor in the system that is not solidly grounded is considered current carrying. So if you're used to using like the Classic, for example, or the old Outback circuit breakers for ground fault, or one of our circuit breakers for ground fault, that's considered reference ground. And as such, every negative in the system is now considered current carrying and requires a disconnect and overcurrent protection as well, meaning everything has to be 2-pole breakers. So with the new ground fault protection, we're looking for differential current, sort of like a grid tie inverter between positive and negative, that allows you to solidly ground the battery negative and make the system a lot safer, in my opinion. So that's kind of a nice feature. The arc fault protection comes with the ground fault protection. It's a kit. You get we'll show you here in a minute, but you get a circuit board and a couple CTs that go in the device. There is a upcoming rapid shutdown transmitter for these as well. So if you're required to do rapid shutdown, we have a 600 volt string level sun spec rapid shutdown device coming to the Canadian market, hopefully here in another 4 to 6 weeks, I think is what I'm being told. That will work with anything, any SunSpec transmitter, but it is string level. It's not module level. Just be aware of that. The other normal things about the Barcelona, like most of our products, battery temperature sensors included, 360 days of data logging, 2 auxiliary outputs, just like the Rosie, where you can do things like diversion or vent fan or whatever you need to do with auxiliaries. And a lot like the classic, Robin insisted this thing talks, so it does have a speaker, and you can turn it off. I did figure that out. And I guess it is good. Some people do enjoy the devices that talk to them. I personally don't like my devices talking to me, but that's the beauty of it. We can have it either way. The MNGP2 does have Bluetooth, and we talked about that a little bit earlier with the 230 50 hertz update question. But the Bluetooth is currently only used for firmware updates. So you take your cell phone, you open up the app, you would connect to the system, and you update whichever device needs to be updated. In the future, we may add monitoring to that if you're local to the device. Speaking of monitoring, I'll go off on a bit of a tangent. We do have a comm box that we're getting ready to start rolling out in a beta form that is local monitoring only at the moment, but we are working on spinning up a server and then cell phone apps. So we'll have the full, barrage of monitoring. But currently we can offer within the next couple of weeks a local monitoring device where if you know how to port forward, you can get to it. And hopefully pretty quickly afterwards, we'll have the cloud and everything going. The Barcelona and the Hawke's Bay are both ETL listed for US and Canada. So just pointing that out. The one thing I do want to point out about the Hawke's Bay and the Barcelona, unlike the Classic, the fans are a lot quieter. They do run a lot more efficient. They tend to be quite a bit cooler. The high voltage is nice where it just allows you to do less strings. Like on a Hawke's Bay 90, which we're getting ready to talk about, you can do one pretty hot string, or 120, you might do 2 strings in parallel, but it allows you to really minimize the combiner box issues, wiring, a lot smaller gauge wire. It's a real elegant way to go, especially if you have any distance to run at all. So the Hawke's Bay is very similar to the Barcelona, except for it's a single MPPT. So it comes in 2 models. It comes in a 90 amp and 120 amp. Both are 48 volts, and both have all the same feature set. You can get the ground fault, arc fault optional kit. They have the 185 to 585 volt DC MPPT range, the same 360 days data logging, the same Bluetooth, same voice. It's exactly the same controller, except for it only has 1 power section instead of 2 like the Barcelona. So it's a pretty nice little controller. I really like this one. This is kind of my favorite. I really like redundancy. So if you've got a system where you have multiple controllers, for me, it's a little bit more money to buy like 2 Hawke's Bays versus 1 Barcelona. But if there is ever a failure, a lightning strike, or whatever may happen, chances of one of them surviving or you still having something working is a lot better. So I really like the smaller, segmented systems. I've got one now, a system I'm working on now with a customer that has 24 600 volt 60 amp charge controllers by somebody else who I won't name. The white ones with the black fins on them, and the BMS opened and they all blew up. And when he contacted the company to talk about that, they said that wasn't a warrantable situation because the device is not intended to have the battery disconnected. So he asked us about ours, and I said, absolutely. Every one of our products is intended to have the battery disconnected while it's running at full tilt. It's not going to keep running, but it's not going to hurt the device. So we're actually installing 12 Hawke's Bays in place of the 24 60 amp MPPTs. And that's just something we've always worked towards, is like, what happens if there's a catastrophic issue and a battery goes away or something like that. Our systems regulate very, very rapidly. And as such, when the battery goes away, you just won't see that spike like you do on some other charge controllers where the battery voltage will run out of sight and it blows the capacitors internally. So that's kind of a nice feature. It's all safe. We're going to talk about another safety feature in a minute, but yeah, I do have a question about 24 volts, and that is something we're working on. Currently, the current system is 48 volt only, but you will see, I believe, the Hawke's Bay and the Barcelona come out in a 24 volt version as well. I'm told it probably takes a different version because of the FETs and or IGBTs or whatever they are internally and some of that stuff. But I do believe you'll see some stuff happening in 24 volt world here pretty quickly. Um, I know it's still pretty common in a lot of places. I'm finding around here most of the newer systems are going 48 because they can buy, the server rack batteries or whatever they end up buying, and the hardware is there to support it. But I know there's a ton of 24 volt systems out there, and that is something that we're definitely looking at. So I'm not going to go through this again. I know you guys want to get to lunch. This is just a pricing example of why high voltage is better than low voltage when it comes to the cost of the wire, the cost of the breakers, the cost of the combiners, and all of that. It's kind of a no-brainer if you can run a single pair of 10 gauge wires back versus number 4 and combiner boxes and everything else. It's going to be less expensive. So the breaker box, again, not really any rocket science here. It's a cast box that matches the charge controller. The one thing I'm going to point out here that's really nice is the breaker for the PV side. We had a lithium battery manufacturer come to us years ago before we even built this product and said that they had a charge controller, who I won't name, that failed internally. And when it did, it passed high voltage through to their battery, and their battery's BMS, because the voltage was so high, when it tried to open, it arced over and shorted the FET internally, and it fed the lithium battery like 400 and something volts. So we really opened our eyes on that one. Like, we have product fail. Everybody does. It's just part of the way it is. So that breaker on the left-hand side in that picture is remote trip. And internal to the charge controller is an analog circuit that's completely independent of everything in the charge controller. And if the battery voltage exceeds 68 volts, it trips that breaker instantly. So that's just a last ditch fail safe before we have any kind of catastrophic thermal event with the lithium battery from overcharging. Just kind of a nice safety feature. It really didn't cost anything to add. We put it in there for the arc fault. Was originally intended, the breaker was originally intended for the arc fault system. So if the arc fault detector detects an arc, it trips that breaker to make the system a little safer. So putting that analog circuit in there cost pennies, really, and it just added that extra level of safety that we hadn't really thought of until somebody brought it to our attention. The Barcelona Breaker Box, exactly the same thing, just twice as much fun. You've got two 30 amp PV input breakers, one on each side, and your main 200 amp breaker. So very similar. The one difference about the Barcelona, in this picture here, it's a little hard to see, but it does have battery studs hanging out of the bottom of it. So a lot like an inverter, if you don't want to run conduit up into it and you just want to connect to it, there's a 5/16 positive and negative stud on the bottom of it where you can land your battery cables external to the box, because remember, it's 200 amps. You can actually remove two little bus bars internally, and you can conduit into it and run your battery cables internally too if you want to run conduit. And this is the options board I talked about. So this little purple board on the left over here on the left is your arc fault ground fault board. So the board under the red arrow on the left, yeah, I think I said that wrong. The picture on the right, the purple board on the left of the picture on the right is the options board that you would get in your kit. The board under the arrow on the left comes factory installed. So that little board just snaps in, and then you wire your CTs in as shown here. So it's pretty straightforward. The instructions are really clear. The ground fault has to have positive and negative through it. The arc fault or rapid shutdown only gets negative. If you're using a Barcelona, all PV wires, go through one set of CTs. So both positives, negatives through the ground fault and both negatives through the other two. And this just shows each one individually, as you would stack them in there as you're building the system. So quickly, I'll touch on this one. This is something that we're getting ready to send off to be listed as well. This is what we're calling our standalone arc fault ground fault detection device. So if you get a system where you have to bring it to code and you need something to detect arc fault and ground fault, this can go in and remote trip a breaker for you and, meet all those current requirements. So you need more information on that, reach out to us, but we'll have a 24 and a 48 volt unit, and it comes as shown with the kit and the CTs, and then you purchase the right remote trip breakers to do what you need to do. We talked about solidly grounded versus negatively grounded, so I'm not going to beat that one anymore. I know it's getting close to you guys' lunchtime. And that's just showing the difference between solidly grounded and reference grounded. A reference grounded system during an active fault can leave systems a little dangerous, in my opinion, because conductors that you might have thought were safe to touch now become hot, and that can be kind of scary. So the one thing I'm going to touch on here, and then I'm going to see if we get any questions so you guys can get off to lunch, is we do have our new, this should not be coming soon anymore, we have our new 500 amp battery combiner. I don't actually have a picture of it on here. It looks very similar to this, just about half the size of the 1000 amp, if you guys are familiar with that. So we now have a 250 amp battery combiner, a 500 amp battery combiner, a 1000 amp battery combiner, and our 2000 amp battery combiner. So we have a whole line of battery combiners now to make it much easier to install these large systems. So that's something that I'm really excited about, because that 500 amp one really fits a need in the industry, in my opinion. And they all have locations for circuit breakers. So you can do, like if you're doing lithium batteries and you want a breaker on each string of lithium, or if you've got multiple inverters, you can put breakers in here. So it's just kind of a very versatile, cool box. And that's just kind of showing some of the wiring of it. So that's kind of it. That's what I've got. Hopefully I didn't keep you guys too long, and I'm going to open it up for questions. I see we've got one about our others doing remote trip features. And that's a good question. I haven't seen anything yet. I think historically the component manufacturers like MidNite or the other ones in the industry that don't do a complete standalone product tend not to worry a lot about the other components in the system that aren't theirs. And so I don't know what others are doing for that, but that is a real issue, because if you take like a Simplify battery, for example, 48-volt battery, and you instantly feed it 500 volts, the BMS in there isn't designed to deal with that 500 volts. And when you start opening FETs under extreme high voltage, a FET will usually fail in a shorted condition. So let's say that it's not even a hardware failure. Let's say that, somebody in the room here takes a Rosie, Hawke's Bay, and they got 2 strings of PV, and they don't quite pay attention, and maybe they get the strings in series instead of parallel, and they feed down 1200 volts instead of 600 volts. That Rosie is going to fail dramatically, and when it does, it's going to pass that through. So that's just something cool to have. AC coupling of Rosie, yes, I completely forgot. We now support AC coupling functionality, and we're working on implementing the menu structure. The hardware is there, and it will frequency shift and everything. We need the menus to drive the frequency shifting, but the AC coupling works amazing. And it is also, I'm told by engineering, protected. I haven't tried this yet, but it runs the same protection that it runs for its rating for UL for the output. So you can, in theory, feed it, unlimited power for 5 minutes and 125% for 10 minutes. So it's supposed to protect. So I am told by engineering that you will not be able to damage a Rosie by AC coupling it. I took that as challenge accepted, but I suspect we'll see the menus for that. Probably, I'm going to say 1st of July, we're hoping for a very big production release. I'm anticipating we'll probably see the menus for that in a couple weeks in beta. And are the BCBs certified in Canada? The 500 amp one right now is awaiting its ATM, authorization to mark. We anticipate having that any day now. I think we're actually sending a sample up to Ed to have in the building up there to evaluate. The others will go probably shortly thereafter. I don't know why they didn't send them all at once, but that was management's decision, not mine. But the 500 amp one will be in the next week or so.
Wonderful. Well, are there any last questions before we sign off here? I'll give it a couple seconds. Ryan, thank you so much for the product updates from MidNite Solar. And yeah, have a great rest of your day, everyone. Thanks for attending.
Thank you all for coming.